Right, good morning, Year 9. So, I'd like you to have a quick look at these pictures, please, and think what links all of these. So, you've got coal, oil, natural gas, and uranium, which you find in a nuclear power station. So, what word links all of these? Have a quick think and write down your answer. Okay, so, the word is non-renewable. Okay, all of these are used as fuel to generate electricity, but they are non-renewable. That means that one day they are going to run out. So coal, oil, and gas we expect to run out within, well, oil and gas within sort of 40 to 50 years, probably won't be viable. Coal, you have about 200 years worth of coal left. However, unfortunately, because it causes a lot of pollution, it probably wouldn't be a good idea to continue using it. Uranium, we have to mine and dig up. We've got lots of uranium actually, probably 1,000 years worth. However, once you've used it, you have to then store it underground for tens of thousands of years because it's very, very radioactive. So there's a big problem with that. Okay, so today what we're going to do is look at other ways that we can generate electricity. So your title for today is renewable energy. So just pause the tape and write this down. And I'm quickly going to go through what we're going to do. So all of you should be able to list examples of renewable and non-renewable energy sources, explain the difference between renewable and non-renewable, and identify pros and cons of the different types of energy resource, and evaluate the impact that scientists can have on the use of energy resources and why they're limited. Okay, so this is how the world generated most of its electricity. And if you have a quick look, you can see what the problem is. In fact, most of you have got a very, very similar pie chart in your book, but you can see here that was a percentage generated by burning coal. That was a percentage generated by burning gas. And if you just take those two, okay, and also nuclear as well, actually, those three are all non-renewable. So you can see a massive proportion of our electricity is generated by non-renewables. So some other ways we can generate electricity: hydroelectric, it's using water from dams. It's quite a big part actually, 16.5%. Then you've got this one, wind and solar, and then other methods that could be things like, well, tidal, biofuels, geothermal. There's a few others in there, so we're going to go through them. But just to go through what some of those others actually were, yeah, tidal, biofuels, and geothermal. So, just to summarise, about 63% of global electricity production comes from fossil fuels, about 74% comes from non-renewables, and that includes nuclear. Hydroelectric is the most commonly used renewable energy source. Okay, that's actually quite important, having a few numbers like that. So I'd like you to pause the tape once more and quickly write that down for me. Thank you. Okay, so just to pick up again, a non-renewable energy source is one that is finite and will run out, such as coal, oil, gas, or nuclear. A renewable energy source is one which is infinite and will not run out, like solar or wind. So essentially what it means is it should continue theoretically indefinitely. For example, there will always be wind. We'll always get temperature differences in the atmosphere, which means that leads to wind, and so there'll always be wind. The sun will continue to shine for, another, well, billions of years, so that's not really a problem. That should carry on indefinitely. However, coal will eventually run out. So, as well as being our main source of electricity, fossil fuels are also our four main sources of energy for transport and heating. So, for example, if we stop using fossil fuels, we'll instantly have to lose our cars. Now, some might say, well, why don't we switch to electric cars? But if we burn fossil fuels to generate our electricity, that's not really going to work. Same for heating. Okay, so we need to find alternative ways to generate the electricity to fund or to fuel heating, but also to fuel transport. So, what is the alternative? Now, what I've done is in assignments, I've uploaded some information cards about renewables. They're on the PowerPoint, okay? And then I've also uploaded a table which looks a bit like this. Okay, what I would like you to do is use the information cards and fill in the table. So these are all the ways we can generate electricity from renewables. So we've got wind, hydroelectric, tidal, wave, solar, and geothermal. What you need to do is read through the information cards and fill in these. Now you might have to write quite small, or if you can't fit it in, you can even go to your book and fill that in there. So firstly, where does the energy come from? The input energy, e.g. is it wind? So kinetic energy, movement of air. Is it light energy? What kind of energy do you think, say, for example, runs wind? Okay, so wind would be kinetic because it's the movement of air. Okay. In fact, what I'll do is I'll go along with wind and explain it. So, renewable energy source, where would you locate it? Now, here's the thing. You can't just put a wind farm anywhere. You have to put it, obviously, where it's windy. So you need to think about where these kinds of places are. So often they're high up. So that means that they are often very visible. And some people don't like that. Often wind farms are offshore, because you always tend to get breezes offshore. So therefore, that could be a problem for things like shipping or for people that like coastal views. So you need to think about things like that. The equipment needed for building it. So how difficult or technical is it to build, say, a wind farm? Okay. The cost of building, is it expensive? Is it cheap? How much do they cost in terms of their payback time? Do they need lots of maintenance, lots of staff? These are the kind of the cost. How reliable are they? So, does the wind blow all the time? Can we predict when it will blow? These are the things. The cost of the electricity. So, we build these things. Is it expensive to actually generate the electricity, or is it relatively cheap? A big one, the environmental impact. So we know, for example, wind turbines don't give off any carbon dioxide that contributes to global warming. They don't give off any emissions at all, so no acid rain. But do they have other environmental impacts that perhaps we haven't thought about? And then overall, what are the advantages of, say, a wind farm? What are the good things about them? Why are they a good way of generating electricity? And what are the disadvantages? Okay, so I've just quickly summarized wind farms for you. Okay, but I would like you to go through the information cards and do that for every one of these. Now that will probably take you about 20 minutes. Okay, so pause the tape now, download the assignment, which is the information cards on PowerPoint and a copy of this table, and then start filling it in using the information cards, and then I'll get back to you until we have finished the lesson off. Okay, so welcome back. Now, for the final 15 minutes or so of the lesson, what I would like you to do is log into Kerboodle. Okay, so here you are, Kerboodle, and then you'll need your email address. There's mine. Okay, yours is like a number at Thamesmead. Your password, in case you haven't worked it out yet, is the first part of your email address. Okay, so it should just be whatever numbers you've got there for the first part goes in there, and then JJ9 is the login. Okay, so log in to Kerboodle. Okay, and when you log into Kerboodle, you should see something like this. So you want AQA Sciences 9 to 1. And then today we're just going to use the digital book. Okay, that's this one. So you should have access to the digital book. And then the first books that you will see, you don't want any of those, are biology, we're doing physics. So we want Physics for Combined Trilogy. Okay, so click on that. And then if at the bottom you type in, I'm already on it actually, but page 34, and then enter, it'll come up with this one. Now, what I would like you to do is read through this page, just skim read it, okay? There's a diagram there showing how a wave machine works. We'll talk about wave. Tells you a little about tidal and a little bit about hydroelectric power stations and also a bit about wind. What I would like you to then do is have a go at questions 1 and 2. Okay. Ignore question 3. Okay. We don't really need to do that just yet. Okay. But I'd like to then have a go at questions 1 and 2 in your book. Okay. By the time you read through these and answer those questions, that'll probably take you about 10 minutes to do that. Then I would like you to move on to page 36 and 37, to the next page. And once again, I'd like to skim read about solar panels. So there's a bit of information here about solar and about geothermal. Okay, so if you want to make a few extra notes on those or fill in your tables with a bit more information from here, you can. I would like you to copy figure 4 into your book and explain how geothermal works, because it's a really good example. It's one that often people get wrong. So I'd like to copy figure 4 into your book and explain how that works. Okay. And then I would like you to once again have a go at questions 1, 2, 3, and 4. Now that will take you a bit longer. Okay, so you can consider that homework. Okay, by the time you read through this and draw that, that'll be about 10 minutes. That'll take you to the end of the lesson. So we'll consider these questions part of your Easter work. Although, to be honest, if you want to crack on and do them straight away, it'll probably take you about half an hour to work through those questions because they're a little bit more complicated. Okay. As you can see down here, there's a question on specific heat capacity, which means you might have to go back and check in your book about specific heat capacity. We did that about 6 lessons ago. Okay, so good luck. I will be online if you need me.